Okay, we're going right to 4.8. We did skip section 4.7 just because I wanted to. That should be good enough, right? I can do what I want. All right, here we go. So section 4.8. We're going to do another kind of proof, but it's very, very different than the proof that we've been doing. All right. Some people like these a lot better than the two-column proof kind of stuff. These are called coordinate proofs. If you don't like graphs, you probably won't like these proofs then, because this is all graphs. Okay, coordinates, and that's what we mean, is these graphs. Okay, coordinate is, you go over x, you go up y, correct? Those are coordinates, ordered pairs and things like that. And we're going to do a proof with coordinates, I should say. All right. Let's do a little background here, and let's see what we're going to have. We have a triangle, and it's on an xy axis. Everybody see that, don't they? All right, so it's an xy axis. What would this point be right here if this was an xy axis? What's the point, though? It's 0, 0, isn't it? Okay. Now watch. Now, I don't have any numbers on here at all, do I? Okay. But this point right here, where the vertex of that triangle on this x-axis, we need to call that something as well, don't we? And we could call it a lot of different things, and we're going to call it one particular thing. But what do you think? Do you know how far over you went as far as number-wise? No, not really. So we need something to represent the measure that we go over. Yeah, you could call it x, but they don't call it x because it's a little confusing. Instead of x, when you go over horizontally, they call that a. So this point right here is point A, lowercase a. But what would the ordered pair be? It's not just, you can't just say it's point A. Is it 0a?
A0.
It's A0, right, because you go over A, whatever that length is. Right, it could be 5, could be 7, could be 27, right? We don't know, so we just named it A. We say the length of this segment right here is A. To tell you the truth, I'll just put an A right here just to represent the length of that segment. Is that all right? So, yeah, I could call this point then would be what? A0. Make sense? Because if this was 5, if the length of this triangle was 5, then what would this point be right here? It would be 5, 0, correct? Yes. All right. Let's see. This is an isosceles triangle, so if this is A, what's this right here then? That length would be A as well. So what would this point, this ordered pair, be up here? It's 0A, right? 0A. And again, if the length of this was 5, what would that point be? It would be 0, 5. You get it? All right, no big deal. So get that stuff down, and that's pretty good. Now, do you have your books open? If you look at page 301, they give you some hints on this. I don't read straight from the book very often, but there are some things that I want you to see in the book. 301, turn there. 301, page 301. Don't just sit there. Move. Where's your book? Get it open. Look at page 301. You see the little example? It says example 1. Looks very similar to this thing right here, but they have quite a bit of writing in there. So let's read off what they've had. Let's see what they're asking you to do. It says position and label right triangle MNP. Well, yeah, call this M, we'll call this N, and we'll call this P. So there's triangle, right triangle MNP. Agreed? It says label the triangle on the coordinate plane. When they say label it on the coordinate plane, that means put it on an x and y axis. Make sense? Now look, I could have done this. Let's see if I can grab everything here. Yeah, group that. Look, I could have done this. I could have put that right triangle right here, couldn't I? That's on the xy plane. I could have taken this triangle and put it right here if I wanted to. I could have put it over here. I could have put it like right there. I could have put it over here in this quadrant, couldn't I? But what they want you to do, when they say put it in a coordinate plane, they give you some hints. Let's put it back where it was. Look at what they say. It says the length of the sides that are along the axis will be easier to determine than the lengths of the sides that are not along the axis. So, for instance, this length from here to here, MP, could I just find the length of that? I mean, technically I could, but I'd have to use Pythagorean theorem and all that kind of stuff. Can I just look at it and tell me what the length of NP was? MP? Probably not. But could I look at just the length from here to here? What if I didn't know that that was A and that was A, but I knew this ordered pair was A0? Could I tell you the length of this? Sure. What if this was 5, 0? What if this point right here was 5, 0? How long would this segment be? It'd be 5, wouldn't it? Make sense? You couldn't very easily see this one right here. You could do some math, Pythagorean theorem, and figure it out. But just looking at it, you might not be able to tell. And that's what they're saying on this little first step right here. Now, it says, since this is a right triangle, the two sides can be located on the axis. So, since it's a right triangle, one of these sides is going to be on one axis, one of the other sides is going to be on the other axis. You get it? That's pretty easy. Look at the next thing. It says, placing the right angle on the placing the right angle of the triangle, angle N, at the origin will allow the two legs to be along the x and y axes. So, again, if it's a right triangle, it was very convenient that the vertex of that right angle was right on the origin. It just made it really easy for us. That's what you'll see why this stuff is important a little bit. Having one side on the axis, having the other side on the axis, and having this point right at the origin makes things very easy for us, because I could tell you very easily the length of this line and the length of this segment right here. Okay? It says, position the quadrant, or the triangle in the first quadrant. Is this in the first quadrant? Yes, it is. It's a lot easier. Why is it easier in the first quadrant than it would be in the third quadrant? Everything's positive, right? The length of this is positive, the length of this is positive. Okay, so that's why it's nice to have it in the first quadrant. We're just giving some hints on how to set this thing up, is all we're trying to do. Let's read the next thing. It says since point M is on the y-axis and its coordinate is 0, its y-coordinate is A because the length is A. So what they're saying is this. Since this is right on the y-axis, the point is 0A. So I know I'm starting at 0 and I'm going up to A. So it's very easy just to look at it and say, oh, what's the length of this segment right here? It's just what? It's just A. That's correct. And the same thing with the x-axis. Since this lies right on the x-axis, it's very easy. If I know this point and this is the origin, it's very easy to look at it and say, oh, what's the length of this segment right here? It's just A. Correct? All right. Let's see what else they say. Since P is on the x-axis, it's the same thing we just said. All right. So basically, those are some hints on how to set this thing up. And that's all we're doing right now. We haven't even done the proof yet, okay? All we're doing is just setting things up, and it's kind of easy when you have it set up like this. All right, let's do another one and see. It's going to take a few of these to figure out what's going on. So let's just get rid of this and do another one. All right, here we go. This is on the top of page 302, and it's example 2. Page 302, example number 2. All right. It says, find the missing coordinates of the isosceles triangle XYZ. All right. This is isosceles. So this side is equal to this side right here. Now let's see what we have here. This point, that's the easiest one right there. What would point X be? 0, 0, because it's at the origin. And notice, they drew this triangle not just anywhere on the x and y axis. They drew it so one of the sides is on the axis and at least one of the vertices is on the origin. It makes it a lot easier that way if you do it like that. Now, understand, the way they drew this triangle, this is not along the y-axis because it's not a right triangle. Make sense? Okay, so we couldn't take this and put it along the y-axis like we did earlier, but we did put it just like this. So let's go to this point right here. This is the next easiest one. What would this point be right here? So A0, that's right, because look, you didn't go up and down at all, did you? If you started here and you went to here, you didn't go up and down, so it's A0. So what's the length of line segment XZ? It's just A, isn't it? Just like we did before, right? This is 0 on the x, this is A on the x, so what's the distance? It's A, right? Think of numbers. Remember, these are representing numbers. If we were 0 here and 5 here, what's the length of it? It'd be 5, wouldn't it? Okay, but we didn't say 5, we said A, so that would be the length here. Now, this is isosceles, so let's think about this a little bit. First of all, let's think about how high up we went right there. Do we have any idea of how high up we go? Did we go A? Do we know that the height of this is the same as the length of this thing right here? No, not at all. All right, we have no idea. Just because this is isosceles doesn't mean that this length is the same as this length. Look, I could have had this point way down here, couldn't I, and still been isosceles. I could have had that point way up here and still be isosceles, but the length is not A. So what are we going to do? If we call this length A, what are we going to call this height from here to here? Good idea. Let's call it b. All right, so let's just call that b. So let's think about this ordered pair. So we go over a certain distance. We're not sure how far we go over, but we do go up a certain distance. How far did we go up? We'll just call it b. Good. All right. What about how far we went over? Now this point right here, what does that point represent? It represents how far over to the right we go and how far up. We already determined we go up b. So what do you think about how far over you go? Do we go over a? Now if you go over a, you go over to here. So for instance,
1/2 A.
Very good. Right, this is exactly half. If you have an isosceles triangle and you drop a distance down right here, you're actually going over 1/2. I'm trying to think if we have had because we actually have a theorem that says this, an isosceles triangle, and if you drop a perpendicular down, that perpendicular. But definition of bisector doesn't say anything about an isosceles triangle. Definition of bisector just says if we bisect an angle, then it splits it into 2 equal parts. Or we bisect a segment, it splits that into 2 equal parts. So definition of bisector doesn't hold here. But we do have a theorem, and I can't even think if we've done it before. But you are absolutely right. If this is isosceles, this has to be isosceles, and we drop this straight down, or perpendicular, it does split that into 2 equal parts. We could do a little proof on it if we wanted to. Yeah, let's do it. Let's do a little proof on it, just real quick in our head. Watch. If these two sides are equal, tell me something about this angle and this angle. Why are they the same? Isosceles triangle theorem. Very good. If two sides are equal, the opposite angles are equal. Okay. If I drop this, now I'm telling you I'm dropping it perpendicular. Okay, I have to tell you that. So I drop this thing perpendicular. So what do I got now? I've got angle, angle, side. The triangles are congruent. What must be true about from here to here and from here to here? They got to be equal to each other, correct? So where is this point? It's halfway. So what am I going to call this? Half of a, or I could call it what? A over 2. All right. So if I have an isosceles triangle and I drop a perpendicular down, it will split the other side into 2 equal parts. We just proved it, didn't I? All right. We proved it by CPCTC, corresponding parts of congruent triangles. See how the proofs come in handy here? Yeah. All right. So that would be your point right there. What are they asking you? This is the answer to what they're asking you on this particular problem. They're just asked, those 3 things right there are your answers. They're asking you to find the vertices of the 3 triangles. That would be A0, this would be 0, 0, and what would this be? Well, you went over half of A, and how far did you go up? We're not really sure, so we just call it B. So we went over A over 2, and we went up B. Yeah, it's not really a proof. Again, we're just kind of working our way up to it. All right, does that make any sense? All right, thanks. Let's stop this and we'll go on to another video.